Hey everybody. So we are gonna do question 3 on the screencast. Um, we've got here, new page. We've got a car that's on the top of a hill. We have the radius of the hill, and we know certain things. So we've got to figure out the angular speed, which is omega, and we've got to figure out the tangential speed, which is vt, of the car as it crests the hill. But we don't know a ton of stuff. We do know the mass, it's 5,000 kilograms, which tells me that the weight, just like I said in class, it's good to, if you know the mass, just right away find the weight, 49,000 newtons. Okay, so we got that. Mass, weight, what else do we know? We know the normal force, Fn, is 30,000 newtons. And we know the radius to be 0.12 kilometers, but I don't like kilometers. So I've got to change that to meters, and I know that in 1 kilometer there are 1,000 meters. Kilometers cancel, and I get 120 meters. Okay, so plan of attack here. I need for omega, that is, let's see, I'm just trying to work through here. Omega's theta over t, I don't know theta, that doesn't help, so I don't want to use that one. I know that centripetal force, though, is, car's on top of a hill, it's all the forces acting, F, G, all the forces acting away from the center, which in this case is my normal force, minus all the forces acting towards the center, which is my Fg. So centripetal force is Fn minus Fg. And I know both of those, so my centripetal force is 30,000 minus 49,000, which is negative 19,000 newtons. So my centripetal force is that, negative 19,000, negative just because it's going down. And I think that, just bring it down here, the centripetal force is negative 19,000, but I also know that centripetal force is equal to m omega squared times r. So, m omega squared times r equals negative 19,000. That negative just means direction, so I don't really need it. Everything multiplied together. You don't really need it. So, I'm going to drop that, and I can find my omega by just plugging in. I have 19,000. Again, that negative just means direction. It's important for dealing with forces, but when dealing with like omega, it doesn't help. All of these are different. I mean, you could look at it as the r being negative because it's below you, but not that important in this case. The m is 5,000 times omega squared. We're looking for omega, so leave that, times 120. Omega equals, kind of skip a step, but I think you can do the math. It's going to be 19,000 over, in parentheses, would be 5,000 times 120, and what I get is 0.032. The units for omega are radians per second. So that is my angular speed. No, it's not, because I didn't take the square root. I'm sorry, it's not 0.033. It is an omega of 0.18 radians per second. I forgot to take the square root initially. So, omega of 0.18 radians per second, which is good. And then to find tangential velocity, a couple ways I can do it, but since I know omega, I know that tangential velocity is omega times r, so I can just do 0.18 times the radius, which is 120, and get 21.6 meters per second. Could have also set it up where I did FC, which is 19,000, is mvt squared over r, and you would have come up with maybe a couple decimals different, but it would have been something around 21.5 meters per second as well. So it doesn't matter which way you do it. This is just the way we did it. Is a little simpler, just mathematically. You're only multiplying two numbers rather than having to worry about all of that mumbo jumbo. So angular speed, 0.18 radians per second. Got to be careful with those units. And tangential speed, vt, of 21.6 meters per second. Really, the key trick on this problem is looking at the differences here. Angular has units of radians per second. Tangential has units of meters per second. And if you're given forces, you got to use those forces to find centripetal. Once you have the centripetal, you have that whole bank of equations that you can use to try and find some of the other unknowns. All right, so tomorrow in class you'll get something similar to start with. All people in group 3 will work together on a similar problem. Might be a little different in terms of, instead of given the normal force, you might get the force of gravity or whatever. It'll be same idea though, that you'll work on, and then we'll get into our groups. So good job, and we'll take it from there.